Good evening, everyone. So today our topic is logistic regression. So what do you mean by logistic regression? Logistic regression is simply it is a supervised machine learning algorithm which is used to predict the probability of input and output we get in just yes and no condition, true, false, or just a zero one condition. Okay. So here is the graph of logistic regression. So we have some of the types of logistic regression. What are the types of logistic regression? There are mainly three types. Regression, second is binomial regression, and third is ordinary regression. Okay, so first, binomial logistic regression. They are generally used for the output variable that it's only two possible outputs, and that have only two possible outcomes. Okay, like when we have just two possible outcomes, like our when we get the output variable in just two possible outcomes, that is only known as what binomial logistic regression. Just in a case like either it will be true or false, or it will be like in yes no condition. That is two possible outcomes. Okay. Then next we have multinomial logistic regression, which means when the output criteria is more than two. That means it could be three, four. It is like that. If we have a probability of like, for an example, we have to predict score of examination, they have either they have passed, fail, or in the basis of percentage, if we are figuring out. So if it is above 70%, 80%, 100%, like this, we have three to four criteria. So that will becomes under what multinomial logistic regression. Okay. Then third we will be having ordinary logistic regression. What do you mean by ordinary logistic regression? It is generally when the output variable have multiple categories that follows a specific order or ranking. Okay, like if we have to categorize in various things, but they have what, like specific orders of making. Okay, if we are having like a bucket of list of materials, like for shopping bags, we have to categorize multiple of items in ranges, like if it is in a low range, in a medium range, or a high range, like this of rating scale. Okay, how does logistic regression works? Okay, logistic regression works by using a sigmoid function to squeeze the output of a linear equation. Okay, it just squeezes the output, that means minimize it by just taking the probability between 0 and 1, predicting the likelihood of category outcome. Okay, then like in the ESO format and like this, and then in the it models the relation between, okay, what it does, it models the relation between input feature and this probability, assigning weights to feature to determine their influence, and uses techniques like maximum likelihood estimation, like that. Okay, like basically logistic regression models what does is that it features the input, and the probability it gets is assigned to the feature to determine their influences. Okay, here we have like this. Suppose we have input feature in a represented matrix. Okay, and the y is what dependent variable. Okay, then if we will apply a multilinear function, then for input value x, then we will get like this: z equals to summation of wi xi plus b, where we have the xi, the ith the observation of xi wi, like it's the weight, yeah, or either the coefficient, and b is the bias term, that will also known as intercept, and we can represent it in this way, like z equals to w dot x plus b. Okay, here we have the graph for a sigmoid function. Okay, now we will be seeing like the logistic regression equation and odds. What is odds in logistic regression? Like it represents ki how likely an event is occur in compared to and it not occurring. Okay, like they are defined as what odd equals to px divided by 1 minus px. Okay, where we have the px, the probability that the output belongs to class 1 only, and 1 minus probability of x is the probability that belongs to class 0 only. Okay, and here the second we have log of odds, that is logit. Then to make the model linear, we take the natural algorithms of odds. This is called what? Log odds or logit. Here we have the expression. Now here is the derivation part. Okay, and then now final interpretation of what logistic regression is that it converts the linear score to into into just of two outputs, that is either in a zero or a one form, either it is true or in a false form. Okay, now we have the terminologies involved in logistic regression. Basically we have number one, independent variable. What we needed in logistic regression is, first is very much necessary, that is independent variable, and second is dependent variable. Independent variable is what the feature value, okay, these are what the input values that are used by the model to make predictions, such as like age, size, distance, or we have taken the examples of rating like that. Okay, then second is what target, that we have the target, that is dependent variable. This is what the output variable that the models predict. Okay, what model predict is what our output variable. Then the third is logistic, which is simonoid function that converts the linear combination of output into values between what 0 to 1. Then we have odds, log odds, and coefficient, that is what weights. These are the values that show how much each independent variable influences the final prediction. Okay, that how much independent variable, like what the input variable influences our final output. Then next is bias, that is what intercepts. These are the constant terms in the model and that represent log odds when all the input features are zero. Okay, when we have the all the input features and log odds zero, then the constant term what is what bias. And the last is maximum livelihood estimate, MLE, which is what the method used to find the best values of weights and bias by maximizing the probability of observing the data. Okay, by observing the data and maximizing to that method to find the best values of what weight and bias. Here we have the evaluation of logistic ignition, like accuracy, precision, and recall. What does accuracy means? Then in accurate values and while prediction, what is the actual accurate value we get? That is, we have the formula of accuracy equals to true positive plus true negative upon total. Okay, and for precision we have like true positive divided by what is precision? Precision is that which focuses on the accuracy of positive prediction. Okay, then recall. What does recall means? Recall is just a measure the proportion of correctly predicted positive instances, like how much correctly our positive instances are calculated among all the actual positive instances. Okay, that is recall. So we have TP divided by TP plus Fn, and F1 score is what harmonic mean of precision and recall. Okay, so how it is calculated? F1 equals to 2 into precision into recall divided by precision plus recall. And the next is area under the receiver operating characteristic curve. Area under the receiver operating characteristic curves. What do you mean? What it is? It is a key matrix for sorry. It is a key matrix for evaluating the binary classification models, to represent the model's ability to distinguish between the positive and the negative. Okay, see, it is written here the true positive rate and the true negative rate. So it is basically used to classify the model between the ability of positives and negatives. Okay, here we have advantages that it summarizes the model performance across the classification thresholds and also uses for comparing different model. Okay, and limitations are that it can be mislead if classes are highly imbalanced and does not show the actual probability outcomes or how well the model predicts the positive cases specifically. Okay, and then the next is area under the precision curve, that is AUCPR. What it means, it is the key matrix of summarizing a binary classifier performance that represent area under the plotting graph. Okay, uh, which is like, see, higher AUCR model is at correctly identifying positive cases. That is, it correctly identifies the positive cases. Okay, the advantages are it informs more than ROC when dealing with the imbalanced datasets, and it also focuses on performance for positive classes. Okay, and the limitations are that it can be less positive to interpret that and then ROC, and it does not account for true negatives. Okay, we have the limitations in the previous one, that is it does not uh, gives us the true positive ones, and here the AUCPR is like it does not gives true negatives. Okay, now pros and cons are like, we have the pros of logistic regression is like, number first is we have the probabilistic outputs, that is extremely the 0 1 membership. Okay, then second is it is very simple and easy to implement, mm, and it is also interpretable. That means that the coefficient shows the effective of features on the outcomes. Okay, and cons of logistic regressions are it assumes linear relationships determines between the features and the logouts of the outcome, and it is sensitive to the outliers. That means it can show the extreme values that can distort the results. Okay, and it is also not ideal for small data sets with many features. When we are having a small data sets and with many features, then it is eventually not ideal for it, because it can lead to unstable estimates. Okay, thank you.